Assalamualaikum, greetings. We are from Group 6 from HS243 and today we are going to be presenting one of the environmental issues we have chosen, which is illegal dumping of toxic waste. Before we get started, let me introduce you to our group members first. So our group consists of 4 members: Muhammad Fahmi Shah bin Muhammad Fauzi, Muhammad Firdaus bin Jusso, Muhammad Tarmizi bin Rosman, and Nazatul Hana binti Nurdin. First, let's take a look at what is toxic waste. So toxic waste refers to a poisonous byproduct which is mainly derived from human activities that poses potential hazard towards health and environment. It normally contains chemical substances, heavy metals, and radiation. Toxic wastes are supposed to be disposed of in a specially designed waste facility with a special care and precaution, and such methods includes bioremediation, which refers to the utilization of microorganisms in order to eliminate toxic waste, and second is incineration, which refers to the activity of combusting waste materials, and the last one is by discharging into a specially built landfill. So the industries which fail to comply with the regulation may confront with a hefty fine and imprisonment. Now let's take a look at the illegal dumping of toxic waste in Malaysia. So in Malaysia, we have Environmental Quality Act, also known as EQA, which is enacted in 1974 in order to safeguard human health and the environment. And the legislation amended in EQA is aimed to regulate waste generation and enhancing waste management procedures. In compliance with Basel Convention, Malaysian Customs Act 1967 prohibits the importation or exportation of toxic waste into our country. As for the illegal dumping of toxic waste in Malaysia, there is this one incident where Malaysian authorities find out 110 containers which consists of toxic waste including lead and chromium, which is discarded at the port of Tanjung Pelepas, Johor in June 2020. And the second incident is the incident of illegal chemical dumping into Kim Kim River in Pasir Gudang, Johor by a tanker lorry, which is believed to be owned by an illegal tire recycling company. Now let us move on to the source of illegal dumping of toxic waste. So we are focusing on two pollutants, which is mercury toxic waste and lead toxic waste. So the source of mercury toxic waste is industrial factories and mining activities, while the source of lead toxic waste is lead smelting plants and also electronic waste. Now let's take a look at the first source of mercury toxic waste, which is industrial factories. So normally toxic waste is being dumped illegally by industries that mostly do not practice a decent toxic waste management system. And toxic wastes discarded from the industrial sector includes mercury, lead, asbestos, and many more. And due to inefficient manufacturing process, some industries ended up producing a massive amount of toxic waste. Some industries resorted to discharge the toxic waste to the environment without undertaking primary treatment, and this is due to the fact that they wanted to avoid disposal fee and also lack of awareness on safe disposal practice. The next source of mercury toxic waste is mining activities. So the mercury toxic waste is mainly originated from illegal gold mining operation, which produces a vast amount of toxic waste through mining operations like open pit mining and heap leaching. And the toxic waste emerging from gold mines are often being discharged directly into water bodies, and such toxic waste we are referring to is heavy metals, in which we are focusing on mercury, and the second one is cyanide. Now, how is the mercury is being used in gold mining operation? Firstly, mercury is used to extract gold, where it binds to the gold and produces an alloy known as mercury gold amalgam, and then the alloy will be heated until the mercury vaporizes, leaving the gold behind. And the vaporized mercury will either pollute the atmosphere or condense back to its solid state and pollutes the land or water bodies. The first source of lead toxic waste is lead smelting plants, also known as lead smelters. So lead smelters can be referred to as manufacturing plants which is designed to process and generate lead. And the process of extracting and smelting produces a vast amount of lead toxic waste. So Some lead smelters resorted to cut off the cost of lead waste disposal and dispose the lead toxic waste through illegal practice. The next source of lead toxic waste is electronic waste, or more commonly known as e-waste. So nearly all of electronic devices like cell phones and laptops contain lead. And one of the most abundant e-waste that we can find in landfills is cathode ray tubes and lithium-ion batteries, which contain a huge amount of heavy metals toxic waste including lead and mercury. The incidence of illegal e-waste dumping is surging every year prior to the increasing productivity of technical innovation, and e-waste is also being exported illegally to poor countries under fake pretenses, and this leads to the abundance of lead pollutants in the environment and hence contributing to lead contamination.
So now we go to the species, physical and chemical characteristics of mercury and lead. Mercury has three forms, which are elemental, inorganic mercury, and organic mercury. Elemental mercury is the most common form. It is a potent neurotoxin that impacts the central nervous system. Whereas inorganic mercury is usually white, except for cinnabar, which is red. Inorganic mercury can enter the body through the mouth and skin from products such as disinfectants and fungicides. Organic mercury, or methyl mercury, is most commonly found in the environment. It is converted from its inorganic form by a biological bacterial process. For the physical properties of mercury, mercury is a heavy, silvery white metal. Compared to other metals, it is a poor conductivity of heat, whereas a fair conductivity of electricity. This metal has the freezing point of negative 38.33 degrees Celsius and a boiling point of 356.73 degrees Celsius, which both are exceptionally low for a metal. Mercury is the only known elemental metal that melts at a generally cold temperature. For the chemical properties of mercury, mercury does not react with most acids such as dilute sulfuric acid, although oxidizing acids such as concentrated sulfuric acid and nitric acid or aqua regia dissolve it to give sulfate, nitrate, and chloride salts. Like silver, mercury reacts with atmospheric hydrogen sulfide. This metal even reacts with solid sulfur flakes, which are used in mercury spill kits to absorb mercury vapors. So now we are talking about species, physical properties, and chemical properties of lead. Lead metal exists as the natural abundance in four stable isotopic forms, namely lead-204, lead-206, lead-207, and lead-208. Metallic lead rarely occurs in nature. Nevertheless, the metal exists in two main oxidation states, lead-2+ and lead-4+, with more stable divalent form in the aquatic environment. Three lead oxides are known, that is lead monoxide, lead dioxide, and lead tetroxide, also called minimum. Lead is found in ore with other heavy metals such as zinc, silver, and copper, and is extracted together with these metals. However, as a result of human activity in the atmosphere, lead metal exists mainly as cerussite and anglesite. For the physical properties of lead, this metal is malleable and corrosion resistant, and it is soft, dense, and ductile. Lead is bluish white when cut, but tarnishes to a drab grayish tint when exposed to air. Because lead is a dangerous substance, it must be handled and disposed of with care to ensure that humans are not exposed. The melting point is 327 degrees Celsius and the boiling point is 1755 degrees Celsius. As for the chemical properties of lead, Lead is a metal with a medium level of activity. Water and most cold acids dissolve it slowly. With hot acids, it reacts much better. It does not burn and does not readily react with oxygen in the air.
Firstly, there are a few things that need to be highlighted in the feed and transport. Feed and transport of pollutant in the environment can be defined as a study on how chemicals degrade and where chemicals travel or spread in the environment, when they are released intentionally or unintentionally. This analysis is a comprehensive approach to understand the chemical in the environment, including a modeling system that illustrates not only how chemicals change in the presence of other chemicals and particles, but also how it moves through water, soil, and air. First and foremost, mercury is a metallic element that exists as a liquid at normal temperature in nature. When the mercury is exposed to the environment, it will reach the surface water sources and groundwater sources and end up into ponds, streams, lakes, and rivers. It can also be transported down the aquatic food chain via bioaccumulation because some mercury compounds are water soluble. High level of mercury has the potential to kill aquatic life and freshwater organisms, as well as disrupt biodiversity and destroy ecosystem. For the transport of mercury in the environment, mercury can stay in the atmosphere for a specific time after being emitted from a source, and then be transmitted to the Earth's surface via wet or dry deposition in elemental or particle form. Direct mercury deposition into aquatic environment via precipitation like rain and snow and surface water runoff may contaminate the water source and create irreversible damage to the ecosystem. Lead exposure is one of the global issues since lead mining and battery manufacturing are common in many countries. For the fate of lead in the environment, lead is released in dust particle form that can remain in the environment for a long time. Fuel containing lead contribute to air pollution, usually in cities. The lead particle will fall to the ground and contaminate the soil. Obviously, soil located near the highway and industrial site have higher level of lead than soil in other places because of their exposure to the dust which accumulate over time. Meanwhile, for the transport of lead in the environment, lead can spread to the water sources. For instance, released iron such as lead tend to leach from soil to the nearest water, lake, river, and reservoir with surface water runoff and contaminate the groundwater sources. When they are transported as dissolved species or travel as particle-associated species in area with heavy rainfall, the dissolved lead can seep through the ground and enter the groundwater table, thus contributing to groundwater pollution.
Next, I will discuss about the impacts of this toxic waste that came from illegal dumping towards the human health and the global environment. For the human health, there are several elements that influence the health effects of a person who are exposed to this type of pollutant, which is lead and mercury. Firstly, the chemical form. For example, the mercury have two chemical forms, which is the elemental mercury and methyl mercury, which they are found in most in dumping site. Next, the dose. The dose is how much a person consume or inhale in a term or in a period, and how much they enter the body. Thirdly, the age. The age is how old the person are when they are exposed to this type of pollutant. Next, the eating practices of seafood. These practices are considered the element because most of the seafood are contaminated with this type of pollutant. Fifth, the route of exposure. This is whether the toxic waste are inhaled or consumed through the nose or through the mouth. Next, the duration of exposure. This is how long a person exposed to this type of pollutant, whether it is in a short term or in a long term period. After that, we will discuss about what are the impacts toward the human health. For mercury, it is known as a neurotoxin that affect both the peripheral, and the central nervous system. By inhaling the vapor, it will affect the person, neurological and immune systems, and also lungs and kidneys, and eventually it can be fatal. So the symptoms are tremors, which is you have a shivery muscle, and sleeplessness, also known as insomnia, or a person have a hard time to get a deep sleep, the loss of memory or amnesia, migraines, and neurocognitive dysfunction. Besides, what are the impacts towards the human health by the exposure of lead? First thing first, lead will retain in our body, mostly in the skeletons, veins, and tissues. There are various symptoms that will be shown by a person who are exposed to lead. In a short-term period, it may cause depression, distraction, irritability, and nausea. On the other hand, if a person are exposed in a long-term period, they may cause hypertension, cardiovascular disease, kidney illness, and decreased fertility. On the other hand, there are also various impacts towards the global environment when they are introduced to this type of pollutant that came from illegal dumping. For the animal kingdom, the excess mercury passes through one trophic level to the next trophic level. For example, when a small fish eat something, maybe rubbish, that have mercury, they are infected by the pollutant. And then, when another big fish eat small fish who are contaminated, the big fish may also show symptoms that they are contaminated by it. So the primary symptoms are ataxia, manifested, blindness, and low respiration rate. For the plants, the mercury exposure will impact both the light and dark processes of photosynthesis. The mercury will limit the sunlight from entering the chlorophyll molecules, leading to photosynthesis failure. Last but not least, when the environment are exposed to lead, it also may show several impacts. For the animal, it will reduce the growth, reproduction, and damage the neurological system in most vertebrates. For example, the symptoms in birds are lethargy, which is the bird may be very tired in a short term, and wing droop, where the wings of the bird will curve downward at the end of it, greenish diarrhea, paralysis, and convulsions. Convulsions is a state where the muscle of the birds will relax and contract rapidly in a term or in a period. For the environment or for our nature, the lead will contaminate the atmosphere, sediments, and waterways. For example, the lead in gasoline contributes to air pollution. It is when a car that uses the gasoline that have lead in it and they release the smoke to the atmosphere, and it will cause air pollution that caused by lead. And also for plants, it affects both the seed germination, root and plant development, and the chlorophyll synthesis.
The preventive measure and remediation approach for mercury. Mercury is a harmful substance if not handled well. According to the Minnesota Pollution Control Agency (MPCA), to keep mercury out of the environment, we must all do our share. When possible, buy mercury-free thermometers, heating or cooling thermostats, alternative types of switches and relays, barometers and manometers. Ensure that mercury-containing items and bulk mercury are recycled. Fluorescent and high-intensity discharge lighting, for example, require mercury to operate. Because these lights are highly energy efficient, they require less power from coal-burning power stations, which emit enormous amounts of mercury into the atmosphere. We can reduce overall mercury leaks into the environment from human activities by appropriately using and discarding these goods. Reduce consumption of raw materials and products that emit mercury is a preventive strategy that is most typically focused at mercury-containing products and processes, but can also arise from better efficiency in the use of raw materials or the use of fuels for power generation. This group of measures could include the use of an alternative raw material, such as natural gas, instead of coal for power generation, or the use of a coal type with special constituents, such as more chlorine, because mercury emissions from burning this type of coal may be easier to control than emissions from other coal types. In some areas, using coal with lower trace mercury level could be an alternative. Mercury concentrations appear to vary considerably in some regions depending on the origin of the raw materials, though this way may have its own limitations. Nonetheless, such mercury emission reduction preventive actions are often cost-effective unless an alternative raw material is much more expensive or there are other issues. Other than that, one of the most potent preventive approaches for affecting the overall flow of mercury through the economy and environment is to substitute products and processes containing or using mercury with products and processes that do not contain or use mercury. It has the potential to significantly reduce mercury in the home as well as inadvertent releases from a broken thermometer, the environment, the waste stream, the incinerator emissions, and landfills. Substitutions are generally less expensive, especially as a larger market demands them. Converting a fossil fuel generating facility to a non-fossil technology would also fall under this category of initiatives. At the same time, assuming that substitution is always a clear winner is a mistake because of current electricity production practices. It is generally preferable to use a mercury-containing energy-efficient lamp rather than a less efficient standard incandescent lamp containing no mercury in the case of energy-efficient fluorescent lamps, as long as there are no competitive substitutes that do not contain mercury. Then, mercury wastes, including residues retrieved by end-of-pipe technology, are a unique type of mercury emission that can have an impact on populations far from the source of the mercury. Mercury waste management, the third control measure described above, may entail rendering mercury-containing garbage inert, followed by controlled landfilling, or it may not. In Sweden, the sole permitted mercury waste disposal technique is final storage of the cleaned waste deep below. While some technical issues of this procedure are still being worked out, mercury waste management has gotten more complicated as more mercury is collected from a wider range of sources, including gas filtration products, chlor-alkali sludges, ashes, slags, and inert mineral wastes, as well as used fluorescent tubes, batteries, and other non-recyclable items. Mercury waste management, as it is now practiced in compliance with national and municipal legislations, needs more long-term control and investment. Mercury waste management is critical for reducing environmental emissions, such as those caused by spills, for example from broken thermometers and manometers, or leakage from particular usage over time, for example auto switches or dental amalgams. Now we go to the preventive measure and remediation approach for lead. According to Earth Repair in 2021, for urban food farmers and gardeners, lead contamination in soils is a major concern. Increasing the alkalinity of your soil is one technique to keep lead from getting into plants. This can be accomplished by incorporating alkaline-based organic matter, additives, or compost. Lead is a cationic metal, which means it becomes less bioavailable as soil acidity rises. By adding compost to the soil, which is ideally good aerobic compost, we are also introducing a varied spectrum of microbes that can bind lead and other pollutants. It can also include humic acid, which binds pollutants for around 2 weeks. Consistent compost treatment as well as compost tea will not only improve your site's fertility, but will also help to immobilize lead through microbial remediation. Even low levels of lead exposure, particularly in youngsters, can cause long-term damage. The most serious danger is to children's brain development, which can result in lasting harm. In both children and adults, high doses can harm the kidneys and neurological system. Seizures, unconsciousness, and death can all be a result from excessive lead levels. So here are some of the preventive measures. First, remove shoes before entering the house because this will help to keep the lead-based soil from entering the house. Second, prevent children from playing on soil. So provide them with a sandbox that is covered when not in use. Plant grass or cover bare soil with mulch. The third one is keep your home well maintained. Because if your home has lead-based paint, check regularly for peeling paint and fix problems promptly. Try not to sand, which generates dust particles that contain lead. And the last is eat a healthy diet, because regular meals and good nutrition might help lower lead absorption. Children especially need enough calcium, vitamin C, and iron in their diets to help keep lead from being absorbed. By practicing these steps, we can prevent our family from the lead exposure.